Alright, so for the video today, we are going to discuss how to use the concept of arrangement and also permutation and combination to actually get the probability for certain questions. Alright, so we have learned how to find the permutation and combination in chapter 2. Alright, so now they extend it to find the probability by using the same concept. Alright, so to get the probability from permutation and combination, generally you need to get the number of arrangement or combination with restriction first, divided the total number of arrangement or combination without restrictions. So the formula is very straightforward. Alright, okay, but of course before you can try the answer from this part, you should have the basic idea on permutation and combination first. Right, okay, then now let's start. For example 19, so there's a team of 5 pupils is chosen from the class of 7 girls and 8 boys. They want to find the probability that the team consists of 3 girls and 2 boys. Alright, so I would like you to highlight the keyword chosen. So chosen tells you that generally you have to use combination in this question. It does not involve any arrangement. So chosen means selection. So you have to use combination here. Alright, so to calculate the probability, right, so you have to include the number of combination with restriction. So with restriction means that you want to have 3 girls and also 2 boys in the group. Alright, so 3 girls and 2 boys. How to get 3 girls? You select it from the 7 girls, a group of 7 girls. So it's 7C3. And you want to have 2 boys. How to get the 2 boys? You select 2 boys from the 8. So it should be 8C2. So this is actually the number of combination with restrictions divided by the number of combination or the total without restriction. Without restriction means that regardless to the gender. Alright, so in general, you want to get 5 pupils from a group of 15 students or 15 pupils. Therefore, without restriction combination will be 15C5. Alright, so if you use calculator to help you, you should be able to get the answer which is 0.326. Alright, so this is how we actually use the concept of combination to find the probability. Again, just to remind you all, the formula for getting probability is what? Is the number of arrangement or combination with restrictions divided by the total number without restrictions. So just bear this in mind, right? Okay, so this question is not hard now. It is quite simple. Okay, so maybe you can discuss a harder one. Let's have a look for example 20. Alright, so I'm having 13 parking space in a row, 9 cars to be parked. Alright, so first question, how many different arrangements are there for parking the 9 cars and leaving 4 empty space? So you're having more empty space than the cars that you want to park in, right? Therefore, you should put in the P. And again, another keyword here to tell you is P is the word arrangement. So it is actually permutation. Alright, so you're having 13 space, but you only want to arrange only 9 cars. Therefore, the formula that you can use is 13P9, which is 259,459,200. Alright, then for the second part, how many different arrangements are there if 4 empty spaces are next to each other? Alright, so you have to imagine that the 4 empty spaces are next to each other. We consider it as one group, one item or one unit. Alright, then you are having 9 different cars. Car number 1, car number 2, until car number 9. Alright, so now you want to arrange all these. How many items do you have in total? You're having 9 cars and 1 unit of empty space. Therefore, you are arranging 10 items. And you can also consider the arrangement in this particular group, the 4 empty space here. Therefore, you can have 4 factorial. But because of these 4 empty space are actually identical, Alright, therefore you can divide it by 4 factorial. So you can see the 4 factorial and 4 factorial can be cancelled off lah. So there are some reference book, they actually didn't write out this step, right? Okay, but it doesn't matter. So you're having 10 factorial, which is 3628800. Alright, so first question number 1 and question number 2, they are talking about the number of arrangement. Alright, then now we go to part number 3. If the parking is random, find the probability that there will not be 4 empty space next to each other. Alright, so again, maybe this question, it looks like a bit complicated for you, but just take note on the question first. Alright, maybe you think about, you cancel off the word not. So if you cancel off the word not, that means there will be 4 empty space next to each other. So what is the probability for you to have 4 empty space next to each other? Generally, it is the question that the answer that we get just now, right? 4 empty space next to each other is this one. This is with restriction divided by the total without restriction. And this is the probability for 4 empty space next to each other. But now, for this question, they are asking for will not be 4 empty space next to each other. That means you need to get the grand total, which is equals to 1 in the probability, minus the probability that you get here, and you should get 0.986. Alright. Okay, so this is the second question. This is one of the questions that involve the permutation. Right. So next. Okay, so Ivan throws 3 fair dice. Alright, 3 fair dice. And then the first part, they want you to list all the possible score on the 3 dice, which give a total of 5. And hence show that the probability of Ivan obtaining a total score of 5 is 1/36. Alright, so now let us define A equals to the total score is 5. And here they want you to list all the possible outcome, possible score. So how can I get a total of 5 if let's say I throw 3 fair dice? So I should have 1, 1, 3. Of course, I will have 1, 3, 1 also. And also I will have 3, 1, 1. So 3 plus 1 plus 1 is equals to 5 as well lah. So when you add all the score here, you will see that the total is equals to 5. Any other possible result or not? Any other possible outcome to get a total of 5? So you should have 1, 2, 2. Then 2, 1, 2. And also 2, 2, 1. I think that's all. Alright. Okay, so how to calculate the probability for event A? Alright, so to calculate the probability of event A, first you need to look at the probability for every single score first. So what is the probability for you to get a 6? To get a 1, it is 1/6. What is the probability for you to get another 1? It is also 1/6. What is the probability for you to get a 3? It is also 1/6. So these are the probability for me to get a score, okay, for every cases. Alright, and then now every single case here is also the same, 1/6, 1/6, 1/6. So you need to repeat the step for so many times. You just count how many outcome that you are having here. So 1, 2, 3, 4, 5, 6. So you multiply your probability with the 6 here, and you will get 1/36. Alright, so the purpose that they ask you to list out is to save your solution and save your steps. Actually, they don't want you to list to write out a very long step. So what they want is like you can straight away multiply with 6 because you're having 6 different outcomes here. So when multiply it with 6, you'll straight away get an answer. Alright. Okay, then if I proceed to part number 2, find the probability of Ivan obtaining a total score of 7. So just now is the probability of total score of 5. Now they want a total score of 7. Alright, so again, for part number 1, these two questions are very similar, right? And then for part number 1, they actually give you a hint already. To get the answer, you need to list out the possible score. Alright, so maybe I will treat this as a hint for me lah. Okay, so to get the total score of 7, so maybe I make it as event B. Alright, so I will try to list out all the possible outcome that I have. Okay, so to get the total score of 7, I may have 115, then 151, then 511. Okay, then I might have 124, 142, then 214, 241, then 412, and 421. Alright, I don't know whether you feel very lazy to write out so long or not. Okay, if let's say you feel lazy to write out so long, then I will bring in the concept of permutation later for you. Alright, but for now, you try to list out everything first. Okay, then for the third one, third possible outcome will be 133. 1 plus 3 plus 3 is also 7. Then I have 313. I have 331. What else do I have? So I still have maybe 223 because 2 plus 2 plus 3 is also 7, right? So 223, 232, and also 322. Yeah, I think that's all. These are all the possible outcome that I might have to get a total score of 7. Alright, okay, then how can I get the probability? If you can list out all the outcome correctly, that means to calculate the probability, it will become very, very simple. That means for every single score that you get is 1 over 6, multiply with 1 over 6, multiply with 1 over 6. And then you count how many possible outcomes that you are having here. So you're having 3, 3, 3, which is 9, 9 plus 6, which is 15. So you multiply it with 15. And from here, I think you should be able to get the answer, which is 5 over 72. Alright, so this actually also involves the permutation and combination, right? Just that you are writing it out one by one. Okay, so this is what you have for example 21. Then maybe we proceed to the last example for this part. So the last example is example 22. Alright, so maybe you can read the question first before we start. Right, so first, they want you to find the number of different ways that the 9-letter happiness can be arranged. Highlight the word arrange. So this tells you that you should use permutation to solve it. Alright, so there are 9 letters in total. So when you want to arrange 9 letters, it should be 9 factorial. But from the 9 letters here, there are some repeated letters. So I can see that you're having 2P and also 2S. So when you're having 2P, you need to divide it by 2 factorial. When you're having 2S, you also need to divide it by 2 factorial. So this is how you get the number of permutation. So 90720. Alright, then next one. The 9 letters of the word happiness are arranged. So again, highlight the word arrange again. Find the probability that the 3 vowels are not all next to each other. Okay, so they are talking about, again, if you are not so sure, you cancel off the word not first. Alright, so maybe you focus on the 3 vowels are all next to each other. So if let's say the vowels are next to each other, that means A, I, and E, I group them as a group. Alright, so I still have H, P, P, and S, S. Alright, so I want to arrange all these letters. So I'm having 1, 2, 3, 4, 5, 6, 7. 7 items. So I will have 7 factorial. But from the 7 items here, I'm having 2P and also 2S. Therefore, I need to divide it by 2 and 2 factorial. Alright, then after that, you should consider the arrangement in this group A, I, and E, which is 3 factorial. So from here, you should be able to get 7560. So the 7560 is the number of permutation that 3 vowels are all next to each other. Alright, okay, then now let us remove the shaded area here. So they are now asking for not all next to each other, and they are asking for probability. Okay, so if I say probability for all next to each other is 7560 divided by the total without restriction. So this is actually the total without restriction, 90720, and not all next to each other means that you have to take 1 minus this probability. Alright, so if you get the answer correctly, it should be 0.917. Alright, so I think to answer all these kind of questions, you need to do a bit of revision for permutation and combination. If not, it will be very hard for you to continue. Right. Okay, then now we go to part number 3. Okay, so find the number of different selections. So highlight the word selection. That means you only want to choose them. Okay, you want to select 4 letters from the 9 letters which contain no P and either 1S or 2S. Alright, so now for any selection or combination case, I think I told you before, if you are having identical item, you need to list it out case by case. Alright, so the first case is you have 1S. The second case is you're having 2S here. Alright, so from this question, they already tell you no P with either 1S or 2S. Generally, you should ignore the P straight away from your selection because no P should be selected. Okay, and then the S also you need to ignore it because these 2S are identical items. Therefore, I already list it out case by case. Therefore, you should ignore it as well. Alright, so you are now, you can see that only 5 letters are available. H, A, I, and E. Okay, so for the first case, you want to get 3 letters from the 5. Therefore, it is 5C3. For the second case, you want to get 2 letters from the 5. So you're having 5C2. And these two are the different cases. Therefore, you need to add them together. So you should get the total, which is equals to 20. Alright, okay, so this is how we actually use the combination and permutation to try and get the probability answer. Alright, so maybe before you answer this kind of question, just make sure that you go and do a simple revision on chapter 2 first. Alright.